Hi everyone, in this video I want to make a couple basic points about electrical power. So the book derives this formula that power is the product of current and potential difference. I'm not going to derive that here, although I will check the units in just a few moments. But now it's important to keep track of what that means. It means the power dissipated by a resistor R or the power delivered by a power supply. And to understand why the difference between dissipation and delivery, we need to go back to what delta V means, the change in potential, for these two cases. For the case of a resistor, we normally talk about delta V, the change in potential, as the potential drop across the resistor in the direction of current flow. Whereas for the case of a power supply or a battery, in the direction of current flow, we're talking about a potential gain. So the difference between potential gain and potential drop is what's causing basically this difference in interpretation for, in the case of a resistor, power dissipated, in the case of a power supply or battery, power delivered, when we're talking about this formula power equals the product of current and potential difference. Now let's check the units. For shorthand, I'm going to use these little brackets to represent units. So this equation reads the units of power equal the units of current times the units of potential difference. So let's plug in those units. The units of current are amps. The units of potential difference are volts, and 1 volt is a joule per coulomb. Meanwhile, an ampere is a coulomb per second. So we now have coulomb per second times joules per coulomb. The coulombs cancel, leaving us with a joule per second, which is indeed a watt, so this all checks out. Finally, I want to point out that in the case of resistors, you should be able to take this formula and derive yourself two more useful formulas for the special case of resistors. If we start with our basic expression for electrical power, we can make a couple of substitutions in the case of a resistor. So we can swap out the current for voltage drop and resistance, and we get the power is the square of the voltage drop across the resistor divided by the resistance. That's very useful if you want to compute power rapidly without knowing the current. On the other hand, you can swap out the voltage drop, or the drop in potential, for the product of current and resistance, and get that the power dissipated by a resistor is the square of the current passing through the resistor multiplied by the resistance. So this is really useful for reasoning about power when you don't have the voltage drop across the resistor. So you should know all these formulas and be able to easily derive both of these from this. Okay, that's it. Thanks for listening.